Welcome to the second video for section 3.5, and we will begin right where we finished off, and that would be with example number 9. Here we are trying to establish the identity, and so we need to look at the more complex side and go from there. And this is the problem right here. It's rather obvious that the left-hand side is quite a bit more complex, and so that's where we're going to start. And if we look in particular in our textbook, we do have an identity that we know tangent squared of u is equal to 1 minus the cosine of 2u over 1 plus the cosine of 2u. And then we still have to multiply that by 1 plus cosine of 2u. And when we do that, this 1 plus cosine of 2u will cancel with this 1 plus cosine of 2u, which equals 1 minus cosine of 2u, which is exactly what we wanted to show, and so we are finished. Example number 10 is the cosine to the fourth of x equals 1/8, then 3 plus 4 cosine of 2x plus cosine of 4x. And hopefully it's rather obvious that the right-hand side is more complex here. And so the first thing that I would probably do here is to take this 1/8 and multiply it out. However, here's a situation where we would run into a mess pretty quickly. And so what I'm going to suggest you do is do the opposite, because trust me, I'm not going to go through the whole thing and then end up having this end up going nowhere. Instead, what I'm going to do is I'm going to take this and show that cosine to the fourth of x is the same thing as cosine squared of x, the whole thing squared. And we know, according to the identity in the book, cosine squared of x is equal to 1 plus the cosine of 2u all over 2. But that's what cosine squared is, so what we need to do is we need to square all that. So if we square that, we would then have to FOIL this out. So that's 1 plus 2 cosine of 2x, not 2u up here, that should be 2x, plus cosine squared of 4x, cosine squared of 2x. Sorry about that. All over 4. Now, believe it or not, we are slowly getting to a little bit better than where we want to be, or where we are trying to get to, and that is the 1/8 times that whole quantity there. And so what I'm going to do is I'm going to realize that cosine squared of 2x can be written as cosine squared of 2x would equal 1 plus the cosine of 4x over 2 all over 4, because all I've done is taken the cos squared, the exact same identity here to give me this, and so taking the identity here, we get 1 plus cosine of 4x over 2. Now, in order to continue, we need to get that numerator to have a common denominator, and that common denominator will be 2. So this becomes 2 plus 4 cosine of 2x, and then this one already had that as a denominator, so it's plus 1 plus cosine of 4x all over 4. Simplifying and adding like terms here, 2 plus 1 is 3 plus 4 cosine of 2x plus cosine of 4x and all over 8. Now the only problem is we need to move this 1/8 out, and so factoring that 1/8 will give us the final answer of 1/8 times 3 plus 4 cosine of 2x plus cosine of 4x. Example number 11 is yet another identity to confirm. We start out with the sine of 4u equals 2 sine of 2u cosine of 2u. Now what I'm going to look at when I try to determine, yes, the right hand side appears to be more complicated, but if I look at it carefully, I see 2 sine of an angle, cosine of an angle. That appears to me to be the double angle formula for sine, and so realize that probably I could get by doing the following. I'm going to rewrite this sine of 4u as sine of 2 times 2u, or this is twice of 2u, which is 2 times the sine of the original angle cosine of the original angle, which is exactly what we want, and so it simplifies or falls out really, really quick. And then finally, number 12, 1 plus 1/2 sine of 2 theta is equal to sine cubed of theta minus cosine cubed of theta all over sine of theta minus cosine of theta. And basically the right hand side is more complex, and so I see this difference of cubes, so I'm going to factor this numerator, and that will give me sine of theta minus cosine of theta times sine squared of theta plus sine of theta cosine of theta plus cosine squared of theta all over sine of theta minus cosine of theta. And notice this factor will cancel with this factor, and so we get the simplified version, sine squared of theta plus sine of theta cosine of theta plus cosine squared of theta. Well, sine squared of theta plus cosine squared of theta I know is 1. So that will make 1 plus the sine of theta cosine of theta. Very, very close to what we want. But then I need to look at where do I want to go. I want 1 plus 1/2 of the sine of 2 theta. Well, that means somehow I need to try and get that shown. And here is really a cheap way to do it, but I know I need to get that to be 1/2 the sine of 2 theta. Well, let's see what we get. 1/2, the sine of 2 theta is 2 sine theta cosine theta, right? And my question is this an equivalent statement of this? All I have done is taken 1/2 and I put the 2 back in, so it's exactly what we had before. So now this is 1 plus 1/2 of sine of 2 theta. And that is exactly what we wanted. It's not really cheating, it's just looking where do we need to go, and then we head in that direction. The next group, 13 through 20, has a lot of problems, similar problems, where we need to find the exact values. And so I will begin on this video and end on the next. Problem number 13. Sine of theta is 1/4. And the additional information says that theta is in quadrant number 1. And I want to find the sine of theta over 2, or half of theta. And so, first thing we need to look at is the half angle formulas. The half angle formulas have pluses or minuses, and that is dependent upon which quadrant is theta in. Now, if theta is in quadrant 1, half of theta would also be in quadrant 1. So we know that our answer has to be positive. So we don't need to worry about the negative, the plus or minus. We just need to worry about the plus because it is positive. And then it's going to be, according to the identity, 1 minus cosine of theta over 2. Well, we have to draw a picture here for theta. And if the sine is 1/4, that would be a 1, that would be a 4, and that would be the square root of 15. So this becomes the square root of 1 minus root 15 over 4 all over 2, which equals the square root of 4 minus root 15 all over 4 all over 2, which equals the square root of 4 minus root 15 all over 8. Now here, with any half angle formulas, I am not going to require you to rationalize the denominator, and so we are finished at this point. I will continue this process in video number 3.